suppose you have two factories located at a certain city, maybe one at Bangalore, Hosur, or maybe another one at Noida, Gurgaon side. However, your distribution centers may be located at Ahmedabad, maybe in Bangalore, maybe at Chennai or some other places. So then you have certain costs associated to transport these productions to these warehouses, where actually the final product is stored for its final destination to customers. So let's say that you have two plants at Hosur and Noida, and you have two transport warehouse at Chennai and one at say Calcutta. Okay. Now Calcutta and Chennai warehouse has certain demands. Say for example, Calcutta center can take X1 amount of the raw material, means the warehouse storage capacity has X1. Similarly, Chennai, the warehouse storage capacity is X2. And X1, X2 has been calculated based on the demands that these warehouses fulfill, which means that X1, X2 is directly related to the actual market demand or whatever happens. Now, you can send and produce everything in one of the plants and send to both these warehouses, or you can produce different items to this, or rather the different amount of items to this production house, and means you can produce certain product of 1,000 entities at Hosur and 2,000 entities in the other Gurgaon or Noida plant, and send it to these two things. Now, transportation problems deals with the decision is that what you will be sending in which direction, means and so that your cost of this sending action is minimum. Okay. So essentially what we are saying is that the definition is that goods are transported from a set of sources to a set of destinations subject to the supply and demand of the source and the destination respectively, such that the total cost of transportation is minimized. So what is the transportation problem objective function is the cost minimization. Okay, what is that cost? Cost is about the cost of unit shipment into the total amount that has been shipped through this path. Now, it is also sometimes called as a Hitchcock problem. We will work out some of the problems, and we will also work it both using whatever algorithm and other approaches. Now, it's sometimes called Hitchcock problem. You don't have to bother much about this. What is a Hitchcock problem? Because it came from a history. Essentially, there are two types of problems. We will again see through examples what is this. A balanced problem is when both supplies and demands are equal. Then the problem said is to be balanced transportation problem. So if it is a balanced transportation problem, things are a little bit straightforward to understand. If it is unbalanced, as in when you have either excess supply, so it's basically a overproduction that you are doing, and when you have excess demand, so it's basically is underproduction or understocking, or it's basically in the firm perspective, it's about lost sales. Okay. Unbalanced problem, we will see how to solve it, and both how to solve balanced problems. So however, for the ease of understanding, we'll start with the balanced problem first. So essentially, unbalanced problem is when the supply and demand are not equal, then it is said to be an unbalanced transportation problem. In this type of problem, what we do is that we basically will see how the approach, but we just keep this name in your mind that we will create a dummy destination or dummy source which will absorb the remaining amount of that unbalanced problem, so that in formulation the unbalanced problem is seen as a balanced problem. How to do, we will see. This is an important thing when you are solving problem from the books or anywhere else, or in reality also. There are multiple decisions and the variables which are involved in such kind of problem statements. In fact, any problem, irrespective of it is a really transportation problem or not, if that can be converted to this logic, that you have a source, you have a destination, you are sending from source or some kind of things to destination, and every path has a cost or has a unit cost or something that associated, you will be able to convert that problem or look that problem or formulate that problem in the form of transportation problem. Okay. So in the transportation problem, you will come with the cost of production, because every warehouse has some cost of production. It is not just that some production entity or some production node can produce a lot more, or the capacity is huge, does not necessarily be always profitable for you. Similarly, there are cost of transportation also involved, because sometimes the path smaller does not necessarily be least cost transportation path. It may so happen that because of some regulatory restrictions, or because of state GSTs or toll or whatever, there are multiple factors, or maybe the carrier or third-party logistics has special restrictions. Cost of transportation not necessarily always be proportional to the distance. That may vary. Then you have a cost of storage. Suppose you supply excessive amount to a particular warehouse, and you have to keep that item in that warehouse for a certain period. So there is a holding cost or storage cost. That is also a critical thing. So while really solving these transportation problems, these decisions may come into picture, and you may have to incorporate these things. However, for classroom exercises, we will try to reduce this assumption, reduce this complexity space, and start with a very basic model and the very feasible solutions. Okay. The other thing is that transportation dependencies that I was just mentioning. It may so happen that your truck can only transport a certain in bulk amount. For example, a truck will contain only if at least 40 items are delivered. It means that even if you deliver one item, you'll have to pay for that 40 items things. So then there is a reason that your delivery will be always in multiples of 40 in order to kind of leverage the benefit that 3PL or third-party logistics partners are giving. And then there are cost of overproduction, underproduction, all these things are there. Cost of lost sales, which is there. So those things has to be taken into consideration. In the basic form, there are basically three methods. It's a spelling mistake. We will talk about these three methods. There may be one or two other methods. Northwest corner cell method, list cell method, and Vogel's approximation method, BAM. We will solve all these methods and talk about how these methods we need to apply when we have a transportation problem at hand. Okay. So how the basic structure now will look like? Suppose there are 4 destination points. Destination can be your warehouse, can be retail distribution centers, or can be anything. So essentially these are the destinations where the material will go. Where products from 3 origins, it can be production house, it can be warehouse in itself. So it can be between production house to warehouse, warehouse to retail distribution. However, there are destinations and there are origins. So we'll have to distribute to these 4 destinations from these 3 origins. This is an example. Each destination has a supply requirement, whereas production house has certain production capacity. As I was saying, that destination will have some constraint, as well as production house will have, production house or the kind of source will have some constraint. In the balanced form of supply, balanced form of transportation problem, the net supply is same as net production, or net demand is same as net supply. Okay, remember that that's a balance problem. Key things, it is not about entity to entity, because they will not match. Else we will obviously dummy source if it is not a balanced. Now, the basic assumption in the transportation problem, or in this basic form of transportation problem, is that cost is proportional to the unit shipped. So therefore, that I was saying, no benefits of bundling of supplies, that is truck load benefits, is not available. So we will assume that your cost is proportional to the amount that you are transporting. That's a basic form. As it becomes more and more complex, we introduce different assumptions into that. The solution complexity will increase, and that requires more advanced algorithm and kind of possibly advanced software tools. So let's try to represent this logically. Okay. So the same problem for destinations D1, D2, D3, D4. When you go through the book, this may be called as warehouses. This may be called as or termed as other, but essentially these are the four final destinations. O1, O2, O3 are my origins. Okay, so from where the means the item is delivered. Now, what is C11? Can you think of?
Cost, sir.
Correct. So C11 is the cost of source O1 to destination D1. Okay. So it is just a problem formulation, generalized problem formulation. C11 is the cost of source 1 to destination 1. So what is Cij?
Cost of transporting from origin I to destination J.
Good. So we will try to follow this convention wherever possible so that we understand exactly when we are writing the equation form, we know how to deal with this ij, or which summation or which parameters or which I or j has to be a moving I or moving j. Okay. Now S1 is the total amount that is supplied by origin O1. Okay, I'll repeat. S1 is the total amount supplied by origin O1. What is D1?
Total supply to a particular destination.
Correct. So total demand at a density at a destiny D1. So whatever destination D1. Okay. So in the balanced form, what is going to be the relationship between S and D's?
Summation of SI equals to summation of DI.
Correct. It should be DJ, but anyway. Okay. So if you look into that, in the left hand side, there is a I variable which is kind of series for I. It's basically origins, and J goes from left to right, the destinations. The reason of saying is that if you keep it in your memory, so that when you are reading through books or whatever book, you understand what is exactly happening, irrespective of whether it represents D1 as D1 or putting it a different name. So my cost of transportation subject to demand and supply matching. Correct. So demand subject to demand and supply constraints. Can someone give me what is going to be the equation form of this problem statement? Think it through. Just try it out. You can write it on paper and then let me know. Okay, we will cover it.
Sir,
yes, please.
So the objective function will be summation of Cij minimum.
Okay.
And the constraint will be summation of Si equals to summation of Dj.
Okay, you are very close. Just C11 is not the total cost.
The Cij. Cij.
Right. Cij is not the total cost. So Cij is the unit cost of transportation. Okay. So you'll have to basically C11, C12, these are parameters of your equation. So you need to introduce what exactly is the variable, which is xij. Xij is the amount delivered from origin 1 to the destination 1 or destination j, origin I to destination j. So essentially your transportation problem objective function is summation Cij xij, means product of Cij xij, sum of that over I and j should be minimum. Okay, we'll see these things shortly and you will understand what I was saying. Okay, so let me just go through the generic form that we have been talking. So just go through that. SI is supply capacity of source 1. Here it is source is written as SI. It is the demand of destination J. Cij is the cost of transportation of I unit from source I to destination J. Xij is the quantity shift from source I to destination J. So you will have the first objective function that we were talking about, minimize summation of Cij Xij I over 1 to m, j over 1 to n, where m and n are the number of sources and number of destinations. Okay, so what was my number of sources? Just the matrix that I have shown. What was the value of m in the picture that I have just now shown a couple of seconds back?
3.
Correct. Okay, such that summation of xij is equal to x exactly s1 and summation of xij equal to d1, and in the balance case, as your friend has mentioned, sum of all si is equal to sum of all di's, but that is not a constraint as such. The constraint is that all the amount supplied from source 1 should be exactly equal to what it is able to produce. All the amounts delivered to destination D1 should be exactly equal to what it is able to absorb. Let us first look into the problem. Okay. So in the northwest corner method, that is one of the algorithm. Now, can you just write down this in your paper? Just take a pen and paper, write down this matrix. You can, for the timing, excessive text you can avoid. You just can put down D1, D2, D3, D4 and 1, O2, O3 and the numbers. We will try to work hand in hand. Okay, that's why I'm asking. Okay, let me know once you have written it. Let me also write it. Okay, so is everybody kind of noted it?
Yes, sir.
Yes, sir.
Okay. Yeah, thank you. So, so the northwest corner method is start with the northwest corner of the table, that is O1 D1. What is the value of this table?
3.
3. So we will always start from that row or that cell. Allocate maximum possible to allocate in this cell. How much can you allocate here? What does that mean? Actually, what you are doing is that you are looking between the root of your first production house and the first destination house and trying to allocate maximum that you are able to allocate in this route. What is the value maximum that can be allocated?
250.
250,
Correct.
sir.
Correct. Why 250? I mean, not for you, someone who has not got 250. Why 250, not 300? Anybody who has not got it, just try it. Otherwise, you will remain confused. Okay, so silence, I'll assume everybody has got it. So it's essentially is that you have a constant of that cell is the maximum destination can absorb is the 250. So how much we have allocated to cell D1 is 250. So write down 250 in O1 D1 cell. Okay, so this has fulfilled the demand of which destination, which is the first destination. So discard the entire column for D1. Okay, so if any constant is met, cancel the row or column. Means since you have already met the D1's constant, which is the demand constant at the destination 1, so you discard the column. And also you reduce your right hand cells origins total supply capacity. What is going to be the origins total supply capacity now?
50.
Correct. So it is able to supply to 300 plus 300 items, but he has already kind of allocated or rather 250 to the first route. So now it will be 50. So now your problem consists of 3 by 3 matrix. Now again start with the northeast or northwest corner of the method. Now what is the northwest corner now?
O1 D2.
O1 D2. How much I can allocate in this route? Somebody else, I mean, I'm sure there are people who might have already solved it, but somebody who is still trying to understand, getting hooked up it, please solve it and also come forward in the discussion. What is the maximum that I can allocate in this cell? O1 D2?
50.
50.
50. Good. Now, which constant I will discard now?
O1 row.
First row. So the first row I will discard now. So I have made the constant for origin O1 and distribution center D1. Now what is my next cell?
O2 D1.
O2 D1. How much I can allocate here?
Zero, because D1 has also already been fulfilled.
Okay. So yeah, that's precisely what I was saying is that because once you have made a constant, discard the entire row or entire column. Okay. So the second, this iteration, your northwest corner is not O2 D1. Anyone
O2
else?
O2
O2 D2.
Correct. How much should I allocate here? Or how much I can?
300.
Correct.
300.
300 or 350?
300 because 50 we had allocated earlier, right? For
Correct.
D2.
Correct. So in the earlier iteration, I have allocated 50 in O1 D2. So at that point in time, reduce that 350 or the demand in the destination D2 to 300, so that you are not forgetting how much maximum is required in this. So now I'll allocate 300 and I will make 400, which is the O2 total supply limit, to 100. Okay. Now, which constant I have now fulfilled?
D2.
D2 column.
Correct. So cancel that cell. Okay. So now I have 2 by 2 matrix. Which one I should start?
O2 D3.
Perfect. How much max I can allocate?
100.
100.
Great. Discard that O2 row and now also change 400 in D3 column to 300. Now I'll start with which point?
O3 D3
Perfect. How much here?
300.
Perfect. So you are now left with 200, 200, which because of this problem it looks simple, but again, if the number of origins and destination changes, it may not be that simple. Okay, so has everyone got this? Simple, right? Anybody has got any doubt, could not understand? It is pretty straightforward based on intuitive understanding of the logic. So please come forward, raise your questions if you are still confused. Otherwise, I'll move on to the next method. So 50 into 1, 6 into 300, like that. Okay. Can you just quickly calculate and let us know what is the value? Four 4400, right?
440.
Okay, thank you. Now question, is this optimal solution? What do you think?
No, sir, because we haven't considered the per unit cost aspect in our calculation.
Okay, yeah, that is one reason. What is the other reason? What could be the other reason? Think it logically. We're just using intuitive way of calculating the least cost. The northwest corner method is just a kind of very broad framework or algorithm, you can say. We have yeah, please go ahead.
If we see row wise, I would have preferred to have my maximum where the cost is least. So like I would have preferred O1 D2 to have the maximum supply instead of where the cost is more. So maybe that is not optimization.
Absolutely, you're bang on target. So that will lead us to our subsequent things. See, the basic thing is that here it all depends on your northwest cell. The choice of D1 and O1 will, if you just change the naming of D1 and O1 and change the shift the rows and columns, you will see you are getting a different solution. Maybe one of them might be optimum, maybe or may not be. But then what is 4400 is? 4400 is one of the basic feasible solution which satisfies your constraint, and certainly this has achieved certain level of minimum among the set of solutions that you have. Okay, I'll repeat again. So 4400 is one of the basic feasible solution that may or may not be optimum, but this is certainly a basic feasible solution to start with. So when you have a transportation problem, first thing, or rather any optimization problem or any work problem, the first thing is to come with a basic feasible solution. Because once you have a basic feasible solution, then there are subsequent optimization algorithms you can choose to make the solution better. I mean, if any of you are or have worked in the past and even in the future, if you're working on a typical advanced AI kind of mechanisms, when the problem space is complex with a lot of variables, typically, even if you are using the most advanced computer infrastructure, the challenge is getting the basic feasible solution itself. So something which satisfies all the constraints, getting it itself is the biggest problem. And because once you get that, you can improve it slowly through a subsequent iteration. Okay. Typically, if you have run GA in a complex problem, and you will see you can code it and do everything, and you can introduce constraints, relax the constraints, but you will see that getting the first genetic mutation itself is the biggest challenge, because that is where is the starting point, and once you know where to start, you can move on, apply other algorithms and heuristics to get a solution. So here also it is something like that. Now, since all of you have got it, I will skip this part. I will anyway share this if in case you have missed it. An important thing that you must notice that it's basically there is a step approach. It's a stepwise degradation. I'm starting from north to east cell to the going to the minimum right hand side corner. Okay. Now, can you solve this? Just try it out. This is basically 3 into 2 matrix, so should not take much time. So you have three production houses, plants in Gurgaon, Hosur, and Ahmedabad. So spelling, just spare with me. And 2 major distribution centers in Bangalore and Mumbai. The quarterly capacities of 3 plants are 1,000, 1,500, and 1,200 autos. And the demands on the 2 distribution centers for the same period are 2,300 and 1,400 autos. If you are comfortable, you can possibly scale it down with hundreds, but that's fine. The mileage chart between the plants and the distribution centers is given in the table. Okay, so calculate an LP first with this and calculate the minimum transportation cost if the rate is 80 paisa per mile per auto. So it's basically per mileage transportation cost per item. Just give it a shot and let me know if anybody gets a solution.
So the values given in the chart is in miles per auto, right? Like from Gurugram to Bangalore, it is 1000 miles per auto. Is it?
Yeah. So it's basically distance, mileage chart is.
Hmm. So sir, I am getting the cost 31,32,000.
Okay, let's wait for others.
Sir, can you please repeat what is the chart like, what it signifies?
So it's
The-
basically mileage chart means distance between two points.
Okay, okay, sir. Okay.
Is it 31,32,000?
I think, yeah, because it's the same thing another person has got. Okay, we'll just give 1 more minute for others who are still trying. And then we'll move.
Yes, sir, it is coming the same.
Okay, has everybody got the same thing? Anybody who has not got that amount or still confused what is what? Okay, for people who are a little bit shy, just in case with an assumption, here 1000 is basically the distance between Gurgaon and Bangalore. Just this is hypothetical problem, so don't worry about that, sir. ये कैसे हो सकता है कि Hosur and Bangalore is 1250. The point here is that 1000 miles, that is the distance, and what is the cost per unit travel is 80 rupees. What is the CII or C11 here? For those who are still confused, what could be the C11? I'll just take these things. Just recall the chart. We have C11. What is the value of C11 here? I can see there is only a couple of you are responding. There are many people whose voice I have never heard. What is the C11 here? C11 is 1000 into 0.8. Correct. Yeah. Okay. So now you have all the C11s, and then you have all the supply constants and all the demand constants. Demand constant here is that what is the Bangalore's demand and what is the Mumbai's demand. Supply constant is how much is that Gurgaon, Hosur and Ahmedabad plants can deliver. Okay, so we will proceed. Now what we will do is the least cost cell method, which is exactly one of your friend has mentioned, is that it may not be the optimal. So I'll always like to use a cell which has the least cost. So find a least cost cell at any given point of time. So this is the intuitive algorithm. This is a little bit more towards heuristic algorithm. Find the least cost cell at any given point of time. Allocate the minimum of demand or supply in the least cost problem. Discard the row or column as applicable. Continue until all the demands and supplies are met. In case of tie, use random allocations. Can you solve the previous problem? Not this one, the one for which. Can you solve this problem using least cost?
So can you go to that slide once again, least
Algorithm.
cost?
So you all have
Yes.
these numbers, right?
Yes, sir.
Okay, perfect. Okay, now I'll go to the.
Sir, I have a
Least cost.
doubt here.
Yeah.
If our objective is to minimize the cost, then why are we allocating the minimum of the demand and supply in that least cost cell?
Yeah, it's
We
a
should.
very valid doubt, and that is precisely what I was asking in the previous things, that how much I can allocate in a particular cell. I will be allocating the amount which does not contradict any of the cell constraint. Okay. So at any given cell, you have identified the least cost cell. Now, what are the two constants working on that cell is your supply constant and your demand constraint. Correct? So the minimum will satisfy both the constant. The maximum will not satisfy the constraint, because you might try to maximum allocate on that cell subject to the fact that it does not contradict your solution, okay, or contradict your constant. When you do that and think, if suppose for a particular cell your supply constant says that 100, your demand constant says 250. Okay, if you on that cell allocate 250, 250 is greater than 100, so it violates your supply constant. However, your supply constant, which is 100, does not violate the demand constant. So that's why I allocate the minimum of demand and supply which is possible. So that is minimum, because if you can think of how you are just basically meeting the constant, is that in case of graphical representation, you ensure that it meets both the constant in that cell. Do you understand what I'm trying to say?
Yes, sir. Understood.
Okay. Yeah, now try that using this method. And let me know the value.
Sir, I got it.
How much is the value?
Acha, yeah. Total value calculate I have to do. I just got a matrix. Okay, sir.
ठीक है, ठीक.
Sir, I am getting 2400.
2400.
Sir, I am getting 2450.
2400, 2450. For someone else. Anyone facing challenge in terms of understanding what to do? Please speak out, because in at least physical class it was possible to go and see if you're really been able to solve it. But here I cannot see what you're doing in the other end of it. So in case you're facing challenge, please speak out.
Sorry, sir, I just made a mistake. It will be 2350, 2450, 2350.
Fine. So you have reduced 2350. Very good. So now we have two solutions, 2400 and 2350.
Sir, here will the answers differ based on which minimum value you took? Like if there are two cells where 3 is the minimum value and I start with 1, so will my answer differ from someone who started with another cell where 3 was the minimum value?
Might change, yeah. We'll have to see based on problem. Because you are just looking basic physical solution and breaking the tie randomly. So there is a possibility answer might change.
I was getting 2850.
2850, okay. Don't worry. I mean, whoever is getting, doesn't matter. As long as you're following the logic. So we have 2400, 2350, 2850. So who is this? I'm sorry, I am not able to see who is this. 2850, who got this?
Sanika.
Sanika, can you try with, you might have this tie and then use some random decision. Just you can try with the other one by the time I'm getting some other answers. I'll just give 1 more minute, 1 or 2 more minutes. You can try by the time. Okay, let's see how much I have got. So again, has everyone got some answer? Let me know who has not yet got any answer, or who is confused in what to do once after first 2 steps.
Sir, I'm not sure. I'm confused how to do this.
No problem. No problem. We'll just see. Okay, let's see. I got 2400. So if someone who has got 2350 will have to see by breaking that things. Okay, let's go to the original problem instead of looking into the solution. Okay, what is the least cost?
Sir, 1D2.
1D2, perfect. How much I should allocate here?
300.
Okay, I mean, you can, those who have not done it can do hand in hand. Let's see. So write down the same matrix in the matrix form in pen and paper. We'll follow the same approach. O1, O2, O3. So I'll allocate first 300 in cell D1. Okay, I circle cell D1. Which row is cancelled or which column has to be cancelled?
O1 will be cancelled.
Correct. So row 1 will be cancelled. And changes I should make to other constraints? Anyone? The constraints are changing because in every iteration the constraints are being fulfilled by certain amount. Therefore, In next iteration, constraints need to change so that you don't get confused with the numbers. Okay. So after the first step, which constant should change? I've discarded row 1, but there is another constant, which is the D2 constant, which should change from 350 to how much? 50. Because I have allocated already 300 for this demand. Now 50 has to be fulfilled. And first row is anyway cancelled out. Now among the remaining cells, which is the minimum cost? It is either D2, O2, D1 or O3, D4, right? Is everybody with me?
Yes, sir.
Okay. So this is what she was saying, is that now how to break the tie. I will choose the random things, and you can also choose the random things. If there are too many similar cost constants, yes, your solutions might differ. So don't worry about that, as long as you are following the logic. So here, what I will do is that I will choose northwest of those two least cost entities, which is like O2, D1. How much I can allocate here? 250. Okay. So when I allocate 250, the entire column 1 gets discarded, and then also the other constant, which is 400, is left out with 150. Okay. Okay, now what is the list? Now it is certainly the other one, because there was a tie here, which is now O3, D4, which is choice between 500 and 200. How much I'll allocate here? 200. So the first D4 column gets cancelled out. The 500 constant changes to 300. Okay. So now left out are 4 cells, 6, 5, 3, 3. Again there is a tie. I will follow the northwest rule, west rule, and I'll choose the 3. But you are free to choose. There is no rule here as such. So I'll choose 3. How much I can maximum allocate here? I believe 50. When I allocate 50, this entire D2 column cancelled out. 300 becomes 250. Now between 5 and 3, which is the least? This is O3, D3, right? And I'll allocate 250 in O3, D3. So the entire this production constant in O3 is cancelled out. The demand constant only I have been able to make 250, so I'm left out with 150, which exactly is lying out there in the second row constant, and I'll allocate that. And now it's all about multiplying these entities to these things. I got 2400. Again, how you're making your tries might change your solution. But the one, has anybody got any doubt here? Okay, fine. If you are not, we'll proceed to the next one, which is called Vogel's approximation method. VAM. It's a little bit more widely used approximation method, but it requires a little bit of close concentration. Now, one important thing is here, when we are kind of using this least cost cell approach. Just now your friend has asked one relevant question, is that in case of tie, which one I'll choose should decide my next subsequent solutions. But there is another thing. Least cost approach is an approach where I am just taking the most convenient way to interpret or to get a basic physical solution. But that certainly might give me an optimum solution. But there is another logic. Instead of least cost, if I just calculate least opportunity cost, what does that mean? Just because I chose the least cost for maximum allocation, I might have chosen in the subsequent steps some allocation which actually is even more costlier. So my net cost might have increased in the system or in my solution. Okay, so that's the kind of principle on which Vogel's approximation method or VAM is built on. For each row, find the least value, that is the cost, and the second least value, and write that absolute difference in the right hand side. That's again operationalization approach. What is the let me know if you are not able to follow the slides because I'm kind of moving here and there, so there may be latency in the internet. So now you are all seeing this slide 7. Now suppose the real numbers, right?
Yes, sir.
Okay, great. Thank you. So if you see that first row, just concentrate on the first row. Your least cost is 1. Okay. And we are saying that we are allocating maximum we can in the least cost. What is the next least cost available in this row? In row for O1, the least cost is 1. What is the next least cost after
3.
1? 3. So 3 minus 1 is basically 2. So what it essentially means is that because I have allocated 1 in this cell, this O1 D2, maximum that I can allocate, I might be basically not allocating maximum to D1. So it's basically in terms of that, if this allocation was not sufficient, next time I would have been allocated on 3. So it's basically trying to find out the opportunity cost, or also sometimes called as penalty. Okay, so it is the what is the maximum penalty in this row that is there. So like for this O1 row, maximum penalty is 3 minus 1, which is 2. Okay, so this is the logic, 3 minus 1, which is 2. And for the row O2, what is the penalty?
5 minus 2.
Correct. So 3 again, then like that. Okay. So similarly, we will calculate the penalty for all the columns also. Okay. Now for those who has never done VAM in their entire life, a questions to them. How can we use those penalties to calculate some basic feasible solution? Okay, if I just put it already. Okay, I'm asking you that you calculated any destination path or source path, possible path which is there. You calculated the difference between the two cost elements. What the cost elements represent is basically cost of transporting certain item through that route. Now, and then you have calculated whatever are the two minimum cost elements in the transportation route, you calculated the difference between them and you are terming it as a penalty. So now like that, you know all the penalties for all your distribution and source locations. So if I have to choose a cell where my objective is to minimize cost, which cell should I choose corresponding to these penalties? I'm trying to let you push thinking that what I am doing, or in fact what the algorithm is doing. I'll come again. Yeah, please tell me.
So where the penalty is more, we'll give the first allocation there so that that constraint is satisfied and we move on to the next.
Perfect. Everyone got this idea? Why should I choose the maximum penalty wala route? So use your, those who has got is perfect, good. For those who are still little bit of confused, use your imagination though, I can take these things from multiple routes. If I don't use this route, then I might have to choose a very costly route. So that's where the maximum penalty wala things hai. So if there is a high penalty, I better use this route first, so that I do not encounter that high penalty which may come as part of my solution. Okay. Is this clear? Okay, we will obviously solve in hand some of these things. For each column, find the least value. So whatever we have done for row, we will do for the column. This is the cost of not using this route, also sometimes known as penalty. Penalty is exactly what I just now discussed. Select the maximum penalty. It may be in the row or in the column. If there is a tie, you can break it randomly. I mean, you can break it randomly. You can have your own algorithm. I typically choose among those where I can allocate maximum. Okay. On the maximum penalty row or column, select the minimum cost cell. Allocate the minimum of, again, demand and supply in this row. Once the demand and supply, discard the row and column. Continue as in you recalculate the penalty, because many of those paths are now not available for allocation after the first iteration. Okay. So this one, if you would like to try in your hand, you're most welcome. I would rather say that you can try it at home. So this is the first iteration when your penalties are 2, 3, 1, and the penalty for the bottom rows 1, 2, 2, 2. Among these three is the penalty minimum cost in that row is 2. Okay. I may be wrong or doing some mistake, so anybody who has got it correct, just correct me. But the logic remains same. 3 is my maximum penalty wala row. इस रो में 2 is my minimum cost wala route. There is no tie, so I do not have any conflict. So now I'll allocate maximum I can without any impacting any of the constraint. How much I can allocate in here in this route? 250, which is a minimum of 250 or 400. Okay. So I'll allocate 250 here, which means all this entire row is now, entire column is now fulfilled. So I can discard it from my solution, and then change all the constants which will be impacted because of this allocation. Okay, which means 400 will be 400 minus 250, which is 150. Now again the calculate penalty in the subsequent iteration. Now if you just see in the subsequent iteration, penalties will change. Now you have only this matrix in your hand. What is the penalty for first row? Anyone else? 3. It's basically 1, and 4 is the next one. 4 minus 1, 3. For this one it is 1. For this one it will be 0. And for this column it will be same, because this column is unimpacted. Any of these constraints has not changed. And for this column also it will remain same. For these 3 columns, because I have discarded, this is again kind of trick, because in the previous iteration I just discarded a column. So most of the column penalties will remain same. Most of the row penalties will change, because only thing that has gone out of my solution space is the D1 column, which is the basically my first distribution center. Okay. So I allocate 250. So I now have 0, 0, 0. I've said this 150. Now go to the next iteration 2. I discarded this column. So I have 150 left out here. Now this is the largest penalty wala cell. I allocate minimum of 350 and 300. So I get 300. So this row is discarded. Okay. Which means this 50 will still be left out here. And then I discard this row, first row. Okay, if If it is not visible, let me do that. I discard this row and then again I calculate the penalty. Now only this matrix O2 wala row and O3 wala row, and for columns D2, D3, D4, only these things will be there. And then some of this constraints has changed. Again calculate the penalty. So now from this is 5 minus 6, 1, 3 minus 3, 0, 3 minus 2, 0, 1. And again calculate the same penalty. The maximum penalty will come out from this row. And you allocate the maximum here. So finally I get, once all the demands and supplies are met, I get the maximum of the allocation. So what I have done is basically allocated 250 here, 300 here, 50 from here, 150, 250 here, 200 in D4. What is the cost?
Sir, 2850, the same.
Okay. So when this practice at home, you may use your, this is how typically you should practice. Practicing it at Excel or all these things is not advisable. So you basically has to manually do these things. Okay. Like I started from here, so every time I change the cell row, I change it, and then I use the penalty as a next item and all these things. Let me show you. So practice this at home as much as you can. You will get at least one problem or maybe multiple and questions. So this typically you'll have to do that. So the idea is not about just solving and getting. The idea is how to solve it and what logic is running, so that at least you know what logic you should, fundamental logic you should apply to get a basic feasible solution. Okay. So like that, you'll have a step 1. Sorry, let me reduce these things. Step 1, then in a step 2, so I wrote the penalties here, penalties of step here, step 1 here, and then in the next step, whatever I have allocated, I change the entire demand column. So there are some calculations mistakes which was there, and then in the step 3, like that. So whatever iterations you will have to do, you will have to do that.
So can you also share that with us?
I will.
Thank you, sir.
Which one? This one? The PDF one?
Oh yes, sir. Like your calculations too.
Okay. No, this I will share that one. Don't worry. So this calculation part I just did like 5 minutes before the class. So I just show you how you are doing it at home, because remembering and not doing mistake is something very important. The algorithm is pretty straightforward. Okay. Okay. Now, how can we use Excel to solve this? Okay, we have used Excel to solve Excel solver. Sorry, Excel. We used solver to solve some of the LP problems. Can we use Excel to solve this? Yes, we can use Excel to solve this. So let's try to solve one problem. Can you just open Excel and try to solve this problem? Let's solve this problem. We know the solution at least. Just remember, Excel will give you optimal solution because Excel will use its own algorithm to achieve optimality. So there is a highest chance that Excel solution might not match with some of these algorithms or the values that you have got in this algorithm. Okay. So long as you are following our rules, business rules and the algorithms, whether you break the ties in whichever way, write down that logic. I mean, breaking down tie is therefore no logic, but you say that because now there is a tie, I'm using this, whatever. Okay. Can try to solve this? Let us, you just open Excel, let us try this together. What we are going to do is first write the problem statement. Okay, I am not writing these big jargon words and all these things. So these are your I assume you are trying to do it yourself also, means at least opening that. So I have these 4 distribution centers. I have these 3 origins. Okay. Then if for each I have certain cost items. What are the cost? Can someone just tell me? Or I can. 328. Okay. Three. 753. Okay. So are you clear with this up till I have not done anything as of now. I've just written whatever is already written there. So what is the total? I'll put it here demand. I'll put it here supply. What is the number? What are the numbers here? 250, 350, 400, 200. And what is the supply constant? 300, 400, 500.
So the
Okay.
cell F7 should be 200. The last one in demand. Yes, this is 200.
Okay, just so that I'm basically solving is that the sum is 1200. 1200, so at least I'm still into my balanced solution zone. Now what I'm going to do? This is basically problem as it is standing today. We have not done anything new here. Okay. Now I'm going to put it as my okay. So this is my demand. This will construct my what? The below row are basically what? I mean, when I'm trying to optimize, these are what? These numbers are my. If you can think of LP, how you have solved in Excel, these numbers are basically my. Guess karo. Anyone? These are my constraints. Okay. Now this constraint in perfect balance problem is these constraints are always equal to constraint. Okay. I'm sorry. So also the below constraints are all equal to constraints. These are the cost elements which is already there. This is the problem statement. Now this is the allocation. Total demand. Now I allocate randomly 1, 1. Okay, sorry. Apparently it seems okay, my Excel is getting hanged. So what I'm going to do is now I'm going to allocate random numbers on these column cells. Let me see. No, it's still hanged. Okay. What next? Anyone? Okay, just come back. What I'm doing here? Come on, guys, speak up. Correct. We are filling the allocated quantities. You remembered when you are solving the LP below में हम लोग बोल रहे थे we'll start with some random allocation of academics and AC time, and then we will use the solver. So this is going to be sum of this is going to be sum of okay. Now what is the total cost? Any taker? Anybody would like to? Multiply between what and what? Right. You just tell me from this Excel because it's visible to you so that everybody gets it. I know you got it. Good. Yeah. Okay, got it. Yeah, I got it that you have got it. Sum product. This is how sometimes the defining range helps when the problem exceeds beyond these things. I have not used much of the range as a functionality, but it should not be that difficult. Okay, so I have got some solution with these things. Now what I should do? Anyone else? I use solver. This is maximization or minimization problem. I minimize this cell. One second here. There was something which was already running. Close. Okay, so fine. So what we should be now doing is to minimize this cell. Minimize this cell subject to these columns meet the supply constant, these rows meet the demand constant, and that thing. So once you do that, you get a solution. You try it at home. Next class we'll just show the solution and share it, because the Excel is creating some problem or
So what
hanging.
is the solving method that we will select?
You select simplex LP. GRC is only if it's really continuous things. You select LP, also use the constant variables and non-negative. Transportation problem will not face much of an unconstant variable, but do that. Okay. You try out some of these things. You change the values, you change the variables and all those stuff, and then we will start from here next class. Okay. I just have to see what exactly is the problem. Okay, guys, I'll stop here. If anybody has any doubts, we'll clarify. Otherwise, those who are comfortable can drop off. I'll be here about a minute or so around.
Thank you, sir.
Thank you.
Thank you, sir.
Yeah, thank you.
Thank you, sir.
Thanks a lot.
Thank you, sir.
Anybody has doubt, raise your hand. Otherwise, I mean, so that others can comfortably leave the class. Okay, I can't see any hands. So I will drop off. Thank you all. Meet you sometime next week. Possibly Wednesday is we will be meeting next week, and then one on Friday. I need to finalize the dates. So then, but we will communicate. And also, I have shared one assignment. I mean, I have given 5 to 6 days time, but for your interest, you may try to finish it early, because you may not get that much time in the subsequent assignments. Okay. Thank you. Cheers all. Bye.